Hi, today we're going to do a question regarding recursions. So the question stands as this: if we have a chessboard, say a 8 by 8 chessboard, we have 8 queens, we have to find the number of ways to arrange these 8 queens so that no two queens will be in the same row, column, or diagonal. So this is a question we have. Now this is a direct case of recursion, um, and the best way to solve any probability of recursion is to build the base steps and then move on from there. So let's start with chessboard. Let's say we draw 8 by 8 chessboard and see how we can do that. Now, there's obviously several ways to arrange the queens, but that doesn't really matter because uh, no matter how we arrange these queens, we will end up with the same number of ways to arrange it. In the sense that, suppose one way to arrange would be, say, put a queen here, then put a queen here, and then go straight here, and here, there, at the end, then here, and finally there. So no two rows have a queen. No queen falls in the same row, column, or diagonal. By diagonal, I don't just mean the diagonal like this, not the diagonal for the chessboard, but also diagonal for each cell. So that could be one arrangement. Now, looking at this arrangement, what can we refer from this? If you observe carefully, we'll see that first of all, if we look at the last queen, say if we look at this queen, so how can we form this queen? So first of all, we can say that how many ways can we arrange? How many ways can in how many ways can we arrange a queen at seven? Say if this one is 7, let's remember like that way. So this one is at 7. This one is at 7 5. So in how many ways can we arrange 8 queens on an 8 by 8 chessboard at 7 5? So that's the number of ways we can arrange this here, but this could very well have been here or here. It could have been anywhere in this particular row. Now, so if it were here, then we would have had to move this from there because we cannot be in the same column. So then this would have been here. So that could have been another possibility. So basically, so no matter where it was, we put the queen on the 7th row, Based on that, we need to reshuffle the other queens so that it follows the rules. And that gives us several ways to make this. So if we have to write this as a formula, or rather as a recursion, as a recursion formula. So say if we have a, if we say ways to arrange, ways to arrange equals to ways to arrange if our queen was at 7-0 plus ways to arrange if our queen was at 7-1 plus so on and so forth till we reach if our queen was at 7-7. Right? Now, when we go to the next, on the sixth row, something interesting happens. Now consider this, if we go to the sixth row, then we cannot put a queen on every row. Why? Because it might clash with another queen which is on the same column or on the same diagonal. If that is the case, then it will violate our rule of not putting queens in the same row, column or diagonal. So we need to avoid that. Other than that, basically everything remains the same. So all we're doing is we're putting a check and doing the same thing again, right? So in the sixth column, in the sixth row, in the sixth row we can, for the sixth row we can write the same way. Instead of 7 we just write 6, but we need a check for queens that has already been put. Right? So in essence to the, with that in mind, let's say we have a method for check called check, which takes in the number of columns and the row number and the column number. So what it basically does is it checks whether if I am on this particular row and this particular column, and I have a list of columns, of course I need that to go ahead and check. If I am in a particular row and a column, I run a recursion and check whether any violation has been made. So that's a pretty straightforward method to write. Now coming back to the primary question. So how do we write the recursion for placing the queens? So let's take a method. Say public void place queens, and we say row, and as usual we take the array of columns and a list of integer arrays named result. This one just contains the number of ways, or sorry, this one contains the integer array containing the queens placed in a particular row. Right. Now in the check method we don't need to check for the row, because since it's a new row that we are coming to, obviously there won't be any queens there because we haven't covered that row yet. There could be queens in a row above that, so the column check is required. There could be a queen in a row above that, so a diagonal check is required. But there cannot be a queen in that row itself, because that is the first time we are computing on that row. So having said that, say we have a final variable which says what is our grid size. Since it's a square grid, so just taking this is enough. Now, if we have reached the end of the grid, that means the row is done. We're done with the row. So all we can do is put in the result. So just say result dot add columns dot clone. We need the clone because if we put just columns, every time we update the column in the array list of columns, so every time we update the array list of columns, it will update for each and every result. We don't want that. We just want a snapshot of the column array at that point of time, and that's what we're going to take. So if we have reached the end and we're good, we're happy, we don't care anything about anything else. But we haven't reached the end. This is where the fun part comes in. We haven't reached the end. We want to reach the end, but before that, we want to place a queen at a position which does not violate any of the rules. So we run through the row. So we loop through the grid size, that is each row or the row in concern here, and we check if we put a queen at that particular position, whether that would be a valid operation or not. So like we discussed the check method previously. So in the check method, we pass the number of columns we have, the row we are at, and the column we are at. So if that check passes, we just put the queen there. Now that we're done with the queen, we records and put other queens. So we just call these queens again. Increment the row value, pass all the columns, and first pass the results. And that's it. Thanks for watching.